Hey, sixth grade. Okay, notes. I'm sorry these are late, so we're going to work on page 28 of our notes. And we're going to be solving one step addition and subtraction equations. 12121, which is palindrome. It's the same forwards as it is backwards. And so we're turning to the next available right and left side page thinking. Right past our understanding equations and solutions. So down here at the bottom we're going to write page 28. Flip this bad boy over. Right, 12121. And so solving one step addition and subtraction equations. And I'm just going to put the EQU for equations. We'll put an equal sign above it so we know it's an equation. Okay. Our objective. I can compute the solution to an equation with an unknown, also known as a variable, by utilizing the inverse operation to isolate, that's a very important word there, isolate the variable. Okay, so in true Miss Lewis fashion, we're going to fold our page in half. So step one. Is to determine the inverse operation for the constant. So the term that is defined as the constant, we're going to determine the inverse operation for the constant. So remember, if you have addition, the inverse would be subtraction. And vice versa. If you have subtraction, the inverse would be addition. Okay? This essentially creates a zero pair. So here we go, step 2. Is to perform the task to eliminate or zero out the constant on the side of the equation including the variable. So you're going to perform the task to eliminate or zero out the constant on the side of the equation that includes the variable. Okay, so an example of this, what I'm talking about here, is if I had x minus 5 equals 6. And I realize some of you can see that answer already, but you're going to perform the task. So this is the side of the equation with the variable, and so this is what we're talking about. So notice I have a negative 5, so in order to cancel it out, I would need to do a positive 5. So this is the side that we're looking at. Okay? Notice this side doesn't have a variable. And our whole goal is to isolate the variable, which means get the variable by itself. Okay? Okay, so here we go, step 3. Whatever you did to the variable side of the equation, you must do to the other side. Okay? So an example of that is just like above. I said x, and I'm going to go up a little bit. I said x minus 5 equals 6. Well, in order, my whole thing here was to get this zeroed out, to cancel it out. So I had to add 5 to make this a 0 pair, which makes that 0. So it essentially just cancels it out. I did that to this side of the equal sign. So now I also have to do this exact same thing to this side of the equal sign. Okay? Same exact thing. Whatever I do to one side, I must do to the other. It's all about balancing the equation. So whatever I do to one side, I do to the other. And we're going to talk about that here in just a moment. Okay? At that point, in a single step equation, step 4, you're going to solve for that right there. And then substitute the solution for the variable in the original equation to determine if it is the correct solution, meaning it balances the equation. Okay? So we have that. We have our step-by-step directions. So now we need to talk about some of the properties of equality. Okay, so here, we're going to go up here to the top. And they're no longer step-by-step directions, but we're going to talk about properties of equality. Okay, you have the addition property of equality and you have the subtraction property of equality. And so that we're talking about today, you also have a multiplication property and a division property, and they all kind of mean the same thing. And so what it means is that two sides of an equation stay balanced or equal when the same, that's a big one, same amount is added to or taken away from both sides. Okay? So an example of this, if I have 5 plus 4 equals 9, if I had 5 plus 4 minus 2 equals 9 minus 2, they are balanced because I took the same amount away from each side of the equation. So they remain balanced. It's the property of equality. That's the subtraction property of equality because I'm taking away. It would be the same thing if I went down here and I said, okay, 5 plus 4 plus 3 equals 9 plus, well, that would be 3 because I have to do the same thing to both sides. Hence the reason whatever you do to one side of the equation, you have to do to the other in order to keep it balanced or equivalent. Okay? So now, continuing on, we're going to do a few example problems, and then we'll do a whole lot more of example problems in class on Monday and Tuesday on day 1. Okay? So, let's talk about a couple of examples and work through them ever so briefly. So here we go. Example number 1. Now, this is just like what we were talking about when we were determining which ones were solutions of equations. And some of you could just see the answer right away, and I told you to go ahead and practice the steps even though you can see them. I'm still asking you to do that. Okay, you have to practice these steps. So, my first question that we're going to talk about is x plus 4 equals 3. Now, the other thing that you guys have to remember as well is integer rules. Okay, so you might keep those integer rules really handy, especially addition and subtraction rules. Okay, so I have my problem, and it says determine the inverse operation for the constant, okay, in order to make it a zero pair. And we're talking about the constant that's on the same side with the variable. Okay, so maybe I need to write that up here. Same side as variable. Okay. Whoop. So we're looking at this one here. This is our constant. So I have addition. What is the inverse operation of addition? It's the opposite operation, so it's subtraction. So I'm going to subtract that amount from there, and it becomes a zero pair, right? So it cancels out. It becomes a zero pair. Okay, because I said perform the task to eliminate or zero out the constant on the side of the equation, including the variable. Okay, so then I move to step 3. Whatever I did, which was subtract 4, to the variable side of the equation, I must do to the other side. So I'm going to come over here and I'm going to say, okay, minus 4. Okay, so then I solve for this right here. 3 minus 4. Well, this is where integer rules come into handy. Okay, because I have 3 and I take 4 away. Well, that leaves me with a negative 1. Okay, so now I'm going to come down here and I'm going to rewrite, and so it's going to be x equals negative 1. Because I canceled this one out, he's gone, and then I solved this one, so everything that was left was x equals negative 1. So I solved for x. So now I have to go back, and I've got to substitute this amount back in there to see if it makes the statement true. So this is my check through substitution. So I'm going to substitute for x. I'm going to say negative 1 and put it in parentheses, plus 4 equals, well, it's essentially like saying 4 minus 1, right, per our integer rules. Okay, and so that gives me a positive 3, because the number here is bigger and it's a positive, this is a negative, so I take the difference between them, and it's 3, and it's a positive 3. So 3 matches this side of the equation, so they match, so x equals negative 1. Okay, this is the way that I prefer you write it right here, so you can line things up and do all of that, especially as we continue to go throughout. But it also looks like this. Sometimes you'll see it like this. Looks like this. Boop, boop, boop. I'm going to do that same problem. So if I had x plus 4, and put that in parentheses, and I've got to do something here, equals 3. So in order to cancel out this 4 or zero it out, what we were talking about is I have to do the inverse. So minus 4. So positive 4 minus 4, when I'm combining like terms, that obviously takes it away. Whatever I do to this side, I have to do to this side to keep them balanced, just like we talked about right up here. So I've got that. So this becomes 0, and then I have 3 minus 4, so now I rewrite. So now I have x equals negative 1. Okay? So just note that that's what it also looks like. So here we go. Let's do another example. Let's do example number 2. I have w minus 6 equals 8. Okay, so going step by step, what do I need to do to the variable side over here, because I want to get w, my variable, by itself. What do I need to do in order to get him by himself? I look at my constant that's on the same side. I've got to use the inverse operation. Well, the inverse operation of a negative 6 to make it a 0 pair, so subtraction becomes addition, and it's still the same number. So whatever I did to this side, I do to this side of the equation. Okay? So now, what that becomes is W. Negative 6 and positive 6 become a 0, and 0 is neither positive nor negative. Okay, so it would either be plus 0 or minus 0. You don't even have to do that. Equals 8 plus 6 is 14. Well, now I need to come down here and I need to check. So I'm going to substitute 14 for W. So 14 minus 6 equals, well, 14 minus 6 equals 8. Does that work? So this is a solution for W minus 6 equals 8. Okay? So at the very, very top of our page, I'm going to scroll back up here. I have an entrance ticket for you guys. When you come see me, on Monday or Tuesday, and my remote learners, you guys will be showing this to me also via email or getting on our Zoom for next week. So our entrance ticket is going to be, come up with a really hard one for you guys. And you're going to have two of them. Two problems here. Let's do n plus 7 equals 25. Now I want to see the steps. The second one that you will do is y minus 19 equals 34. Okay? Those are the two problems that I want you to complete before you come to class with your notes. You can put them on the left-hand side of your notes and show them to me. You can put them on a sticky note and show them to me, but I want you when you walk into class to leave them right there. Okay? So, that concludes our note pages for today. I hope you guys have a fabulous weekend.